In this video, we're going to look at the properties of exponents, and we're going to work a few problems using these, work a bunch of examples. If you don't have the properties of exponents written down someplace, I would pause this video right now and write them down someplace handy, so while you're working you can refer to them until you have them down pat. So let's look at some examples just using these properties. In these examples, I want to write in the form a times x to the n, so a number times my variable raised to a power. This first time one, I have 3 times x to the second times 5 times x to the seventh. We can take advantage of the commutative property of multiplication because this is just 3 times x to the second and 5 times x to the seventh. So we can move those around, so it's 3 times 5 times x squared times x to the seventh. And 3 times 5 is just 15. X squared times x to the seventh, that's our multiplication property over here. We multiply exponents, or multiply powers. They have the same base. We can just add the exponents together. So we say 2 plus 7 is 9. Let's come over here to the left. 3x squared times 4x to the negative third. I'm going to do this a couple ways. First, I don't like negative exponents, so I'm going to rewrite this as 3x to the second power. This negative exponent, I'm going to use my negative property here, take it down into the reciprocal, or into the denominator, so that's going to be 4 over x to the third. So with this 3x squared, I'm using my property over here. When I'm taking a product to a power, I take everything inside to the power. So this is going to be 3 to the second power times x to the second power. Whoa! Times 4, and this is going to be over x to the third power. And now I'm going to use my commutative property again. I'm going to say 3 squared is 9. I'll take the 4 over with the 9. I got x squared. And on the bottom I got x to the third. So that's going to give me 36. When I look at this x squared, x squared over x to the third. That's 2 minus 3. So that's 36x to the negative 1 power. Now, since my instructions say rewrite in the form a times x to the n, I'm going to leave this one with a negative exponent. If my instructions were to say rewrite with only positive exponents, then I would rewrite this one as 36 over x. Doesn't really matter. This is the way to do it if you don't like to deal with negative exponents. If you don't mind negative exponents, we're going to pull this off to the side. I'm going to rewrite this. 3x to the second times 4x to the negative third. I can just say I got a negative exponent. Who cares? I do my power of a product to make this 3 squared, x squared, 4, x to the negative 3. I'm going to make my 3 squared 9, move the 4 over next to it, x squared, x to the negative 3. Now I can go 9 times 4 is 36. And here I'm multiplying again. So when I multiply, I add. I'm going to add a 2 to a negative 3. So I'm going to say 2 plus negative 3 is negative 1. Ta-da! I got the same answer. I must be right. Oops, it's not there. It's there. Which way do you want to do it? What works best for you? If you don't like working with negative exponents, Make it positive and work with fractions. If you don't want to work with fractions, leave it negative. Be careful working with your negative exponents. Last one over here. 4x to the third times 2x to the negative second over 6x squared all to the third power times 3x to the fourth raised to the negative second power. This is getting a bit absurd. Hey, I like absurd. So, what can we do? Again, one thing we can always do is say, let's get rid of the negative exponents. So I'm going to rewrite this with only positive exponents. So 4 is positive, x to the third is positive, 2 is positive, x to the negative 2, that's a negative exponent, so I'll put that on the bottom. Now it's positive once I've moved it to the bottom. On the bottom I have this 6x squared to the third power, and I have this, but that's all to a negative power, so I'm going to move the whole thing up top. Oops, not negative. That makes that positive. Now notice, on here, the whole parenthesis was to the negative power, so the whole thing moved to the top. In this 2x to the negative 2, only the x is to the negative exponent, so only 2 goes down, or the x squared goes to the bottom. The 2 stays right where it is. Now I can take this, and I'm basically using the order of operations. I'm going to, before I deal with all my multiplication in here, I have an exponent on a parentheses. I can't do anything inside the parentheses. I can't do anything. That's as simple as I can get it. So now I go to the exponents, and then I'll go to the multiplication. So I'm going to make that 4x to the third times 2 times 3 to the second times x to the fourth raised to the second is going to be x to the eighth. Because again, when I take a power to a power, I multiply those exponents. On the bottom, I got an x squared, I got a 6 to the third power, and I have an x to the second power raised to the third, which is going to be me 2 times 3 is 6. Now I'm going to break this up, and I'm going to separate this into numbers and variables. So I got, on top I have a 4, I have a 2, I have 3 squared, which is a 9, and I have 6 to the third power, which is 36 times 6 is 216. That's just all my numbers. Now I'm going to use my variables, and I have on top x to the 8th, and on the bottom I have an x squared and an x to the 6th. Okay, so if I multiply my numbers out, I'm going to get 72 over 216. And with my variables, I have x to the 8th on top, and x to the second times x to the 6th is x to the 8th on the bottom. Oh, wow, look at that. Because anything divided by itself is 1, or x to the 8 minus 8 is x to the 0, which is 1. So my variables are going to cancel out. And I just have to take 72 over 216 is going to be 1/3.